Okay, fifth graders, so today we're talking about the shapes of the base, faces, edges, vertices. We've been talking about that in class quite a bit. There is a quiz, actually not a quiz, it's a test coming up, and it will look just like this. So you're going to need to know these things, and you're going to need to be able to fill in a table like that. So you've got a cube. It's our first shape. Shape of the base, if you look, if it's truly a cube, the shape of a base should be a square. And number of faces, those are the flat sides, 1, 2, 3, 4 as I go around, plus the bases, 5, 6. And we've discovered before that when it's a prism, if it's a rectangle or a square prism, it's always going to have 6 faces. Number of edges, think of a curb like you're stepping off the curb, 1, 2, 3, 4. And we know it's going to have the same on the bottom, 5, 6, 7, 8, but don't forget the sides, 9, 10, 11, 12 edges. And then vertices. Remember, if you have one, you call it a vertex, but we're looking at more than one. Vertices or a vertex is a point. 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Points or corners, or however you want to talk about it. We said it's when the two line segments come together where they meet. And in this case, it's actually 3 line segments coming together. All right, we're going to switch it up. This time we're going to take out a rectangular prism. Remember, prisms have 2 bases, and the bases are parallel. And we know that the sides are always either rectangles or squares. But a square is a rectangle, so we could just say the sides are always rectangles. Okay, rectangular prism, shape of the base. On this one, it is a square, but it doesn't have to be. It could be a rectangle. So I'm going to call it a rectangle. And a square is a rectangle. And then number of faces. I'm looking at my spelling of rectangle, and it doesn't look quite right. I'm going to fix that in a second. Number of faces. We've got 1, 2, 3, 4, plus our base, 5, 6, just like we talked about it before. And then number of edges, think of stepping off a curb, 1, 2, 3, 4, 5, 6, 7, 8, and then our sides, 9, 10, 11, 12, 12 again. And then number of vertices, points, 1, 2, 3, 4, 5, 6, 7, 8. We've got 8 again. Boy, look at our numbers are the same. Now we're going to take a triangular prism. Remember, prisms have to have 2 bases, no points. Points are pyramids. So we've got our triangular prism here. Alright, rectangle. This is bugging me. I got to fix it right now. Rectangle. Alright, triangular prism. We know that these are our bases because our sides have to be rectangles, and these are triangles, so we know that this has to be our base. Shape of the base is a triangle. And then number of faces, 1, 2, 3, 4, 5, so 5 total. Number of edges, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then number of vertices, or corners, or points, however you want to phrase it. 1, 2, 3, 4, 5, 6. A hexagonal prism. Now, I don't have a hexagonal prism. I have, no, I lost it, a pentagonal prism. So we're going to have to pretend that there's one more side on this as we're thinking about it. We know that its sides are going to be rectangles. We know that the shape of the base should be a hexagon, so we can count our sides. Shape of the base, hexagon. Number of faces, we would have 1 on each side, 1, 2, 3, 4, 5, and if we had that other side, we'd have 6, 7, 8, so there should be 8 on that one. And then number of edges, we would have 6 here, 1, 2, 3, 4, 5, plus the missing side, because this is the wrong shape. So 6 and another 6 would make it 12. 13, 14, 15, 16, 17, plus the missing side would make it 18. And then number of vertices, 1, 2, 3, 4, 5, plus the missing one would be 6, and then down here another 6, that would make it 12. And based on the pattern above, figure out faces, edges, and vertices of an octangular prism. So now I don't have a shape like that. We're going to just have to look at our pattern above. Octangular prism, what would the shape of its base be? An octagon. Number of faces, we know it would have 8 going around plus the 2 bases. 8 plus 2 is going to make it 9. Number of edges, we know that it will have 8 on the top. I'm just thinking here. It would have 8 on the top and it would have another 8 on the bottom, which would make it 16. Plus the ones on the side would make it 16 plus 8, so it would be 24 edges. Did I count that right? I think oh, here we are. 24 edges. No wonder I can't find it. And number of vertices. What did we notice about number of vertices? Anything here? It seems like vertices are less than edges. Is there any pattern to it? 8, 9, 10, 11, 12 went up by 4. 6, 7, 8, 9 went up by 3. So this was a difference of 4. This was a difference of 3. Hexagon, 12 to 18 was a difference of 6. Interesting. I never noticed this before, you guys. 4, and these two shapes are the shape of its base is a 4-sided shape. This one was a difference of 3, and the shape of its base was a 3-sided shape. This one 6, shape of its base was a hexagon, 6 sides. So if the shape of its base is an 8-sided figure, we would expect it to go down by 8. So 24 minus 8, 16 for that one would be my best guess, and you can try it out and find out. What is the relationship to the shape of the base and the number of faces, edges, and or bases? Well, we noticed one right here was that, let's see if I can put it into words. The number of vertices is, let's see, is the same as the number of edges minus the number of sides on the base. Okay, that was one thing I noticed. Is there anything that you noticed? How much did this one go up? This one went up 10. This one went up 4. I'm not seeing a pattern yet. This one went up 6. Not seeing a pattern there, but I'm sure there are other patterns, kids, and if you see another one, please write it down. All right, moving on. This time we've got pyramids. Pyramids have one base, and they have that point on top usually, unless you turn it on its side. The shape of its base, let's find this one first, a triangular pyramid. No, this one we can't call a triangular pyramid because it's got a square at the bottom. We can call this one a triangular pyramid because it's got all triangles. Now, as we've talked about in class, which one is the base? Because sometimes kids will turn it that way and say that this is the base because it's on its side. That's not true. Remember, the sides of a prism, am I saying it right? Nope, sides of a pyramid, they are always triangles. So you can see that these 3 triangles are all the same size and the same shape. This one is different. It's a triangle, but it's a different size and shape, so we know that this one must be the base. And the shape of that base is a triangle. Number of faces, 1, 2, 3, plus the bottom makes it 4. Number of edges, 1, 2, 3, plus the bottom, 4, 5, 6. And number of vertices or points. 1, 2, 3 plus the top makes it 4. A square pyramid, that's the one I grabbed earlier, and we know that this is the base because we know that the sides on a pyramid must all be triangles, so the shape of the base must be, or the base must be this square right here. So shape of the base is the square. Number of faces, 1, 2, 3, 4 plus the bottom makes it 5. And let's see, number of edges, 1, 2, 3, 4, 5, 6, 7, 8. And number of vertices or points, 1, 2, 3, 4, 5. Okay. Pattern you figured out based on number of faces, edges, and vertices. Well, we noticed up here that it went up, or actually it went down based on the size, or the number of sides on the base. Let's try it here. This one went down 2, and this one went down 3, and the shape of the base was a triangle, so it was 1 less than the shape of the base, and here again it's 1 less than the shape of the base. That's interesting. The other thing is, this is a 3-sided shape, and the number of faces was 4. This is a 4-sided base, and the number of faces is 5. Well, how about this one? This might have been a pattern too that I missed. The shape of the base was 4, number of faces was 6. 4, number of faces was 6. So this one actually went up 2, up 2. Let's try the triangle. Shape was 3, and it went up to 5. Oh, so you added 2 each time. Hexagon was 6, plus 2 would have made it 8. Octagon was 8, and if we went up 2, it would have been 10. It was. So let's follow that pattern down here. 3, and you added 1, and you got 4 faces. This was 4, add 1, and you get 5. So based on that pattern, whatever you put down here, add 1, and it should tell you the number of faces. So if it's a pentagonal pyramid, I'm not sure if I've got one. I have a pentagonal prism. You've seen it before, and we can kind of use this as our model. Pentagonal pyramid, the shape of its base, of course, would be a pentagon. And if we had a 5-sided shape plus 1 more, the number of faces should be 6. 1, 2, 3, 4, 5. Let me think on this for a sec. Alright, so I'm going back to this shape and just thinking about adding one more side. I was having too hard of a time visualizing it with a prism. So number of edges, we know that we would have our 5 on the bottom instead of our 4. We would have 5 on the bottom plus an extra one over here. So 5, 6, 7, 8, 9 plus our extra would make it 10. And if we had that many for edges, it looks like we could take the shape of this base and say plus 4, because this one was a 5, so it seemed like if you actually subtracted 4, we would get 6. So number of vertices, my prediction would be 6. Let's think, if this was a pentagon, we would have 5 down here, plus 1 at the top would make it 6. Alright, so relationships that we noticed a new one, that if you add 1 to the number of sides on the base, it will equal the number of faces. And then we also noticed the same pattern over here, well, a similar pattern over here. Here we subtracted the shape of the base, and